Hello students. So in last lecture we discussed about introduction part and adsorption. In this lecture we will discuss about distinction between adsorption and absorption, mechanism of adsorption and types of adsorption. So what is the difference between adsorption and absorption? So first point is to discuss about differences between them. So adsorption is a process which takes place on surface only. That means it is surface phenomenon, while absorption is applied to whole bulk of the substance. So that means, as mentioned here, so the substance is concentrated only at the surface and does not penetrate through the surface to the bulk of the adsorbent. It is adsorption. And in absorption, substance is uniformly distributed throughout the bulk of the solid. So example of chalkstick is mentioned here. When we dip chopstick in the ink, the surface retains the color of the ink due to the adsorption of the colored molecules. That means in ink we can consider two different particles or two different substances are present. One is a dye which gives color to the ink, and second one is a solvent which keeps it in liquid state. So we have solvent and solute, two different things. So solvent particles are smaller in size, while solute particles usually they are larger in size. Suppose we have solution of NaCl, then solvent is water which has smaller particle size or molecular size, and solute is NaCl or salt which has comparatively larger size. So solutes are comparatively bigger in size and solvents are in smaller in size. So smaller size particles of solvents can go deep inside, and a larger sized particle of dye or solute will remain on the surface of chalksticks. So ink colored portion of ink is adsorbed on the surface of chalkstick, and the solute of ink will be absorbed. When we break the chalkstick after dipping it into the ink, you will notice surface of chalkstick is colored and the inner part is wet but colorless. Okay, so it represents solute is adsorbed on the surface while solvent is absorbed inside the bulk of chalkstick. Okay, so both type of phenomenons are observed in the single practical. Okay, so on the breaking of chalkstick, it will found to be white from the inside. A distinction can be made between absorption and adsorption by taking the example of water vapor. Water vapors are absorbed by the anhydrous calcium chloride but adsorbed by the silica gel. That means when we use anhydrous calcium chloride, then when we break it after placing it for several minutes or several hours in open atmosphere, it will absorb the moisture present in the atmosphere and you will notice it is wet from inside. On the other hand, silica gel, when we place silica gel in open atmosphere, after few minutes or hours, you will notice it is also wet but on surface only. It will be completely dry from inside because it adsorbed water vapors. So adsorption concentration is uniform throughout the bulk of the solid, while in adsorption only surface contains the higher concentration of second particle. So both adsorption and absorption can take place simultaneously also, and the term sorption is used to describe both of the process. So here is an example of adsorption, absorption and sorption. So in first example, the concentration of substance is increased on the surface of our solid. So that's why it is called adsorption. So, concentration changes occurs on the surface only. In second case, concentration of substance is increased inside the bulk. That's why it is called absorption. The substance is uniformly distributed inside the bulk. So it is example of absorption. And in third case, concentration increases on the surface as well as inside the bulk. That means both process at the same time, so it is called sorption. Okay, so we have example of adsorption, absorption and sorption. Now adsorption arises due to the fact that surface particles of the adsorbent are not in the same environment as the particle inside the bulk. So what it means, so let us understand it with diagrammatic representation. So suppose we have solid particles, that means a solid block, let us say of a metal, and these are the metal particles combined with each other, and a straight line between them represents bonding, and let us assume all of them has coordination number equals to 4. So as we can see, if we concentrate on the particles which are present inside the bulk, okay, they are highlighted with circles. So as we can see, as mentioned, coordination number of this substance is 4, so that means it needs to form 4 bonds like carbon. So particles present inside the bulk are completely satisfied, or their bonds are 4, that's why they are stable. But surface particles, as for example, if we talk about this particle, so this particle has only 3 bonds. That means it is not satisfied or stabilized, because it needs 4 electrons to share with. So that's why this bond will remain empty, nothing will be attached with it, and that's why it will be reactive. And whenever gaseous particles come in contact with this surface, it will feel attraction towards the particle and it will be adsorbed on the surface. Similarly, if we observe this corner particle, okay, so corner particle has bond from the bottom side and from the left side. We are talking about this particle, but top side and right hand side do not have any particles. That's why it will be even more reactive than this particle. Okay, so because of not completely satisfaction of bond, these type of surface particles will be comparatively reactive. So that means inside the bulk the adsorbent all the forces acting between the particles are mutually balanced, but on the surface the particles are not surrounded by atoms or molecules of their kind on all sides, and hence they possess unbalanced or residual attractive forces. Okay, and these forces of adsorbent are responsible for the attacking the adsorbent particles on the surface. Contact to the adsorbent increases with the increase of surface per unit mass of adsorbent at the given temperature and pressure. So in short, meaning of the second statement is, so when we increase the surface area, adsorption increases, because more and more inside bulk particles will move on surface. When we cut the substance, then new surface will arise, that means surface area increases. So if you are using finely divided powder form of solid, then it will give us extremely large surface, and we will discuss about it in our colloidal portion. Okay, second portion of this unit, colloidal particles. So let us move on. The extent of adsorption increases with the increase of surface per unit mass of the adsorbent at the given temperature and pressure. Okay, so when we keep temperature and pressure constant, and if we increase the surface, then adsorption also increases. Another important factor featuring the adsorption is heat of adsorption. During the adsorption, there is always decrease in residual forces of surface. So that means residual surface, that means simple thing, when we suppose let us assume, as mentioned earlier, we have a solid substance, and solid substance has imbalancement at the surface because surface molecules are not covered
from all the sides like this. Okay, so when inside the bulk particles are balanced completely because they are surrounded with the same kind of particles, surface particles are imbalanced because they are not surrounded. So residual forces, that means these type of bonds which are not satisfied. Okay, so all these type of bonds represents residual forces. So when adsorption occurs, let us assume these are our solid particles and these type of particles are gaseous particles which will feel adsorption on the surface of this solid. Okay, so when gaseous particles is moving, then it has some kinetic energy, and at that time before the adsorption this residual force is not balanced, that's why it is reactive, and reactivity, that means it will have more energy. So this has kinetic energy and surface particles have residual forces which has comparatively reactive. So when this gaseous particle feels adsorption on the surface like this, okay, so this gaseous particle is adsorbed on the surface, so kinetic energy of gas is loosed, that means it is now completely removed, it is not moving around, and it has now steady state on the surface of this solid block, and residual forces of this solid is also balanced. So that means energy must be transformed into something else. Okay, residual force energy or reactivity and kinetic energy of these gaseous particles both are removed, so that means energy of one type is converted into second type, and this second type of energy is heat. Okay, that means initially it was residual force plus kinetic energy of gaseous particles, and now both of these type of energy will convert in heat. So that's why adsorption is exothermic process, it will lose heat.
So these residual forces of surface, that is, there is a decrease in the surface energy which appears as heat. So adsorption therefore is a invariably exothermic process. In other words, delta H of adsorption is always negative when gas is adsorbed. The freedom of movement of molecule becomes restricted. Okay, so freedom of movement of gaseous molecules will be restricted, that means they will lose their kinetic energy. So this amount of decreased in entropy of the gas after adsorption, that is delta S, is negative. So adsorption is thus accompanied by the decrease in enthalpy as well as decrease in entropy of the system. For the process to be spontaneous, the thermodynamic requirement is that at the constant temperature and pressure, delta G must be negative. Okay, that means there is a decrease in Gibbs energy, and we already learned about it in thermodynamics unit. On the basis of equation delta G is equal to delta H minus T delta S, delta G can be negative if delta H has sufficiently high negative value, then as T delta S as positive. Okay, so that means we need a higher negative value of delta H so that we can obtain negative value of delta G. So thus in the adsorption process, which is spontaneous, a combination of these two factors makes delta G negative. As the adsorption proceeds, delta H becomes less and less negative. Ultimately delta H becomes equals to T delta S and delta G becomes 0. At this state equilibrium is attained. That means reaction will stop, adsorption will stop, and we will discuss it, visualize it in with diagram.
Okay, so we have some gaseous molecules and surface active substance, that means it will adsorb these gaseous molecules, and residual forces are represented with different color, so we can easily observe them. So when these gaseous molecules come in contact with this solid substance, they will be adsorbed on the surface. So two different things will happen with delta H and delta S. Suppose this first molecule, it's adsorbed on the surface. Okay, so that means energy of surface is decreased because it is slightly balanced. So if energy decreases, that means delta H will become negative, because before reaction energy was more and after reaction energy is less. So after reaction minus before reaction will be negative. At the same time, delta S also becomes negative because random movement of gaseous particles is decreased. Initially 5 particles were moving randomly, and now one is stabilized on the surface, that's why 4 are moving. So entropy also decrease. Okay, so that means before reaction and after reaction, if we calculate it, then delta S also becomes negative. Both of them becomes negative. But as the number of particles adsorbed on the surface, value of delta H, negative value of delta H starts decreasing step by step, and negative value of delta H is increasing step by step. Eventually delta H and T delta S, eventually they will become equal, and that's why our delta G will be 0 at that time, and after that point we can say that equilibrium is attained because full surface is already covered. Okay, so no surface is left, that means no adsorption can takes place. At that time delta H and T delta S will be same, and that's why delta G will become 0. Okay, so full surface will be covered. Now next thing is type of adsorption. So there are mainly two type of adsorption of the gas on solid. If accumulation of gas on the surface of solid occurs on the account of weak van der Waals forces, that means when solid substance and gaseous particles only feels attraction towards each other and they are not chemically bonded with each other. So because of weak intermolecular attraction van der Waals forces, the adsorption is termed as physical adsorption or physisorption. They are not connected with each other with chemical bondings. And when the gaseous molecules or atoms are held on the solid surface by chemical bonds, the adsorption is termed as chemical adsorption or chemisorption. Any metal can physisorb any gas. All of them more or less feels attraction towards each other. On the other hand, chemical bondings requires specific type of structures. No random gases can connect with each and every metals. Okay, so chemical bonds may be covalent or ionic in nature, and chemisorption involves a high energy of activation and is therefore often referred as activated adsorption. Okay, high energy of activation, that means if reaction is spontaneous or non-spontaneous doesn't matter, they require specific push, energy push to start the reaction. As for example, suppose we have matchstick, and combustion of matchstick is, we know that it is spontaneous. Whenever we ignite the matchstick, it will release high amount of heat because it is exothermic reaction and it is spontaneous. But to start that reaction we have to provide some heat via friction to the matchstick. Okay, if we place matchstick on the table, it won't start reaction itself. You have to provide it some kind of heat with the help of friction so that it can start the reaction. Similar example we can consider example of petrol. If we place a glass of petrol on table, it won't start releasing heat itself, but if we ignite it, if we provide a spark to the glass of petrol, it will start combustion reaction and then whole reaction will complete itself. Okay, so initial help to start the reaction is called activation energy. So because chemical adsorption requires activation, it is referred as activated adsorption.
and sometimes these two processes occur simultaneously, and it is not easy to ascertain the type of adsorption. A physical adsorption at a low temperature may pass into chemical chemisorption as the temperature is increased. For example, dihydrogen is first adsorbed on the nickel by van der Waals forces. Molecules of hydrogen then dissociates to form hydrogen atom, which are held on the surface by chemisorption. That means, as mentioned in previous point, adsorption is exothermic process, and physisorption is easy process. So in the initial adsorption, physisorption will takes place because it has lower amount of energy, and when the adsorption occurs, adsorption is exothermic. That's why more and more heat will be produced, and with the help of higher heat, requirement of activation energy will be fulfilled, and then chemical reaction may start, or chemisorption may start.